Today we look at the process of making weapons. It will be a factory for the production of small arms with a long barrel and the production of ammunition. Production usually takes place in factories, where employees work with only minimal help from robots. There are a few different ways that gun parts can be manufactured. The most popular methods include casting, injection molding, or machining. Guns have to hold up against immense pressure and power. However, the casting process can leave gun parts too weak to stand against this level of wear and tear.
Come on.
First part of gun production is called forging. This is one of the older iron working processes known to man. It was used by ancient blacksmiths, and the same principles apply to the present day, even if the tools used are different. Iron and steel pieces are heated to red-hot temperatures, at which point they become soft and easier to shape. The red-hot pieces are then hammered into the shape of the finished components, and then cooled down. In many cases, a specially shaped die is used and the red-hot pieces are placed into the die and hammered to their final shape. One of the advantages of the forging process is that it compacts the metal and makes it stronger. Forging is the process of heating metals and hammering them into a desired shape. The smaller parts of a firearm, such as the hammer, trigger, or pan, began as red-hot pieces of iron being hammered into a die to give them the rough shape of the finished piece. This reduced the amount of metal that had to be removed to achieve the final shape. Modern power-driven forges could make larger parts, like the receiver for the M1 rifle, but the theory is the same. An advantage to forging is that the process compacts the metal, making the final product stronger. These days, we have large forging machines that can hammer out larger components, such as receivers and barrels of rifles easily. Second part of gun production is called casting. Casting is a process where a mold of a desired shape is initially prepared, then molten metal is poured into the mold and allowed to solidify. Casting is also an ancient metalworking process and has been used in history to make intricate shapes as well as large objects. While a cast metal part is not as strong as its forged equivalent, it is often used to make complicated shapes which would be uneconomical to make with any other technique. One more advantage of casting is that many parts may be cast at the same time. Small parts could easily be cast from molten metal. Since the parts conformed closely to the mold, minimal work was necessary in finishing. On the flip side, cast parts may have microscopic cracks and flaws due to factors such as uneven cooling, lack of proper venting, etc. Third part of gun production is called machining. After a part is forged or cast, it is usually close to the required dimensions, but not precisely so. It may also have tiny burrs and surface imperfections on it. This is where the task of machining comes in, to size the part to the proper dimensions, and polish it as needed. Machining the parts to greater precision also makes parts interchangeable. Machining is also needed to cut rifling in the barrel. The introduction of machinery made interchangeability a practical matter. The new generation of machines introduced in the mid-19th century, coupled with a system of gauges developed by armory employees, resulted in the first fully interchangeable machine-made weapons. Modern machine tools have taken the process a step further, turning out parts to tolerate that can be measured in the thousandths of an inch. There are various machining operations: cutting, turning, drilling, polishing, grinding, etc., and there are specialized machines to perform each task. Fourth part of gun production is called stamping. Stamping is the process of cutting and shaping parts out of sheet metal. Unlike forging, stamping is usually done to cold metal. Stamping is typically used for parts that don't take as much heavy load, for instance, a trigger guard or a magazine. With modern technological improvements, stampings can be used to also manufacture upper and lower receiver parts for some submachine guns and battle rifles. Forging and machining are expensive and time-consuming processes. Non-critical parts can be fabricated by the less expensive method of stamping and bending to shape. The appearance and finish of such parts may not be as fine as a machined part, but functioning is not changed. The use of stamped trigger guards distinguishes the M1 made during the Korean War from those produced earlier. Stamping is also used to put serial numbers on various parts of a rifle. Fifth part of gun production is called woodworking. Back in the days, when stocks were made of wood such as walnut, beech, ash, myrtle, etc., the art of woodworking was used heavily in the gun trade. A skilled woodworker would take a block of wood and, using various tools such as lathes, chisels, planers, etc., would carve out gun stocks, to which the barrel and firing action were fitted. On more expensive models, craftsmen would engrave patterns, cross hatches, inlay precious metals, etc. into the stocks. These days, stocks are made of other materials as well, for example plastic, fiberglass, composite, metal, etc., where woodworking skills are not as important. However, some of the finest shotguns and rifles still feature wooden stocks carved by very skilled craftsmen. Sixth part of gun production is called metal treatments. The various metal parts of the firearm may be treated via chemical processes to add a thin coating that prevents rust and also may be wear resistant. Some parts may also be hardened after machining so that they can bear the stresses of normal usage better. We studied many of these treatments earlier, e.g. case hardening, bluing, parkerizing, tenifer, melanite, etc. Seventh part of gun production is called assembly. After the parts of the firearm are manufactured, they still need to be put together to make a functional firearm. The process of putting the parts together may involve tasks such as riveting, welding, gluing, tightening screw threads, lubricating, etc. A part of gun production is called testing. After the parts are put together, the firearm needs to be tested to make sure that it is functioning accurately and reliably. In some countries, there are standard tests that are enforced by the government, and any firearm marketed in these countries is required to pass the standard tests before it can be sold. All reputable manufacturers also run various tests during various stages of the manufacturing process to catch any problems as soon as possible. Nearly all small arms ammunition cases are of brass alloy. Some use aluminum, steel, or plastic, but the brass case is most popular and easiest to manufacture. The design of the case is determined by the firearm in which the ammunition is used. The typical brass case is formed from annealed sheet by drawing with a multiple punch and die set. The first stage of the multiple die set forms the metal, the second stretches the metal deeper, the third forms the rim, and so on. Each step stretches the metal slightly farther until the final stage produces an accurately formed case. The cases are trimmed to length, and the primer hole is punched. Heat treating and stress relieving are performed to selected types of cases to improve durability. This is accomplished in large batch ovens, where baskets of cases are heated with enough temperature to gently soften the metal without distorting it. When cooled, the metal is relaxed, and better able to take the punishment of firing. Some handgun caliber cases are nickel-plated for durability in reloading, corrosion resistance, and for appearance. Each case is stamped with information such as caliber, manufacturer, munitions codes, and year of manufacture. The assembly process for the cartridge components begins with a thorough cleaning and polishing of the case by a vibratory finisher. The finisher works by vibrating a corn byproduct, dried and ground corn cobs, with a polishing compound around the cases, creating a high luster. Thus prepared, they are ready for final assembly. Sizing the case. The cases are fed into a loading press which first sizes the case. This sizing ammunition forms the metal case to standard dimensions. The case must be within 0.001 inch for it to function correctly. Inserting the primer. The primer is then pressed into the case primer hole flush with the base. The primer must be flush, or the cartridge will not feed properly in the weapon magazine, causing a jam. At the same time, the mouth of the case is slightly expanded, in preparation for receiving the bullet. Charging the case. The case is charged, or filled with the correct amount of propellant. This step is of utmost importance, for miscalculation or double charging could be disastrous. Assembling the bullet. The bullet is firmly seated into the open end of the case. The bullet has a coating of lubricant to prevent corrosion and assist in the assembly process. The bullet is then crimped into the case, to give the correct overall length of the cartridge. The crimp reduces the diameter of the open end of the case and captures the bullet tightly, sealing the assembly together so moisture cannot invade the powder. The press used to assemble cartridges must feed each component accurately, and in the correct sequence. Otherwise, cases could be unprimed, powder left out, or bullets seated incorrectly. Any of these could result in a misfire or loss of accuracy at the minimum, and, at worst, cause the firearm to blow apart upon firing. In each stage of the process, special dies perform the important assembly function. The dies are made of tooling carbide for long life, and have close adjustments to produce quality ammunition. After assembly, the finished cartridges are packaged, usually 50 to a box, and prepared for shipment to the shooter. And now, quality control. Most manufacturers shoot thousands of their own cartridges as part of their quality control programs and processes. The accuracy, pressure, reliability, velocity, and consistency are all recorded. The weapons used for this are specially made, highly accurate, and equipped with data-gathering electronics. Each production run of a particular cartridge is given a lot code. This number, printed on the ammunition box, allows ammunition to be inventoried and traced. Should a particular lot show problems in the field, that group can be recalled and replaced using the lot code system.
Ano pag-insert?